In this video, we're going to learn how to graph piecewise functions. And before we do, we need to go over a definition that is continuous function. A function is continuous, or says right here, a function is continuous if its graph has no gaps or holes and can be traced without lifting the pencil from the paper on which the graph is drawn. So if I look at my key functions from the first video, all of these are continuous except for one. Which one of these is not continuous? Hopefully you said this one here. Remember, this one is an example of two different linear functions. Okay, so we're not talking about this one, but all of these other ones can be drawn by not lifting my pencil. They're all connected. This one, however, you've got two separate parts. There's no way to draw this graph without picking up your pencil. You have to do one little portion, pick up your pencil, and draw the other one. So this is an example of something being discontinuous or not continuous. So we're going to be asked if it's continuous, and that's going to be a yes or no answer. Now, for this function, it's defined as x minus 1 if x is less than or equal to 2, and x squared if x is greater than 2. So I first need to graph my function, find its domain and range, locate any intercepts, and then say whether it's continuous on its domain or not. So for part A, when we graph, we need to make two separate tables for our two separate equations. So my first one is y equals x minus 1. And my second one is y equals x squared. The important part of this graph is that it stops and starts right here when x is 2. So my first point on both of these needs to be that critical portion of when it changes from one equation to the next. Then you want to pay attention to these signs here. On this first one, it's when it's less than or equal to 2. So I'm going to come over here and make a little note with a solid dot that I know this one needs a solid dot, while this one is only greater than 2. So I know this one here needs a hollow or an empty dot. So if I come over here to this one, plug in 2 into your function, you got 2 minus 1 is 1. And it says here when x is less than or equal to 2, so I need to find another point in this domain, in this group of numbers. So a number that is less than or equal to 2 would be 1. And so let's plug in 1. You've got 1 minus 1, which is going to be 0. So I can go ahead and graph this one. And we know from this right here that this should be a linear function. This is your y equals mx plus b. So my first point is 2, 1 with a closed circle. And my second point is 1, 0. So here is this graph right here, x minus 1 when x is less than or equal to 2. So always go from that first point through the second point. So do something similar here. I'm going to plug in 2 here. 2 times 2, or 2 squared, is 4. And then I want to pick something else that's in this criteria of numbers or in this domain. So when x is greater than 2, a number greater than 2 is 3. You can pick any number for these other ones. So I could have picked 0, -1, -2, -3, so on. I could have picked 4, 5, 6, and 7. It doesn't matter what other numbers you pick. but it's just easier to go smaller numbers. And so plug that in. You've got 3 squared, which is 9, and that's not going to exactly fit on this graph. So let's go ahead and plot the point that we can fit on the graph. We've got 2, 4, and I've made a note here that this needs to be an open circle. And then we have 3, 9. So I'm just going to kind of make some dots. This would have been 3, 5, 3, 6, 3, 7, 3, 8, and about 3, 9. And that x squared tells me that this is going to be a parabola with some kind of U shape. So you don't exactly want this to be a straight shot. You kind of want this to have at least a little bit of that curve with that. Okay, so those are my 2 point, or my second equation, my second part of this piecewise function. So part B, I need to find the domain. The domain is all of my x coordinates. And remember, we go from left to right. My first thing I hit is an arrow. So this is negative infinity. And then it comes over here, and notice that I have a break. But is this 2 included? Well, it's included here and it's not included here. So the 2 is at least included in my domain. So I don't need to take a break here, even though it's breaking. It's breaking along the y's, right? But it's not breaking along the x's because I do have an x at 2. So it's not breaking, it's not breaking. And then the last thing I hit is an arrow. And so this is infinity. Spoiler alert, your domain for all piecewise functions are going to be negative infinity to infinity. So then your range, remember we go from bottom to top, and notice, as I already said previously, we have a break here. So when I go from bottom to top, the first thing I hit is an arrow, so it's negative infinity. And so then it keeps going until it hits right here at y is 1. Now at y is 1, that point is included because it's got a closed circle, so this is going to get a bracket. So then union, it doesn't hit 2, it doesn't hit 3, but we do finally hit that graph again at y is 4. But because this is an open circle, you have a parenthesis, and then it's going to keep going forever because it hits that arrow. On C, I need to locate any intercepts. We seem to struggle what intercepts are. Intercepts is where does this graph cross this x-axis and where does this graph cross this y-axis? So my x-intercept, it crosses this right here at the point 1, 0. And then my y-intercept, where is it crossing this y-axis? It's crossing it right here at this point, which is 0, negative 1. And then lastly, D, is this function continuous? Well, it's got a break and a hole. My definition was that it has no gaps and no holes. And it can be traced without lifting a pencil. None of those things can happen here. So this is not continuous. Let's try another example. Example 3, we have a function and it's defined as negative x plus 3 if x is less than 1. 3x minus 1 if x is greater than or equal to 1. So let's graph. My first equation is y equals negative x plus 3. And my second one is y equals 3x minus 1. I at least need 2 points in here. The point that we have to pick is 1, because that's where it shifts from one equation to the other. So I'm going to put 1 in here first. In this first equation, 1 is not included, so that's going to be an open or a hollow circle. But it is included right here at 1, so this one will be your closed circle. Okay, when x is 1, you get negative 1 plus 3, so this is 2. And then pick some other point that meets this criteria. We have when x is less than 1, where less than 1 is 0. When I plug in 0, you get negative 0, or just 0 plus 3, which is 3. So I'm going to plot my 2 points. At 1, 2, we have a open circle, and then it goes to 0, 3 right here. And you always go from the first point through the second point. So here's my graph of the first one. And now let's go to the second one. So let's plug in 1. 3 times 1 is 3, minus 1 is 2. And then we have x is greater than or equal to 1. So something that's greater than or equal to 1 is 2. So 3 times 2 is 6, minus 1 is 5. So I'll start at the first point, which is 1, 2. Well, we already have that point, and now it is closed. And then 2, 5. So this one is my piecewise function. If at this critical point here, which in this case is 1, if you get the same thing as we do here, I'm going to just jump to part D. That means that yes, this graph is continuous. So I didn't even need to graph this. Once I saw that this is 1, 2, and 1, 2, right where this is supposed to be breaking, when this is the same, that automatically means that this is going to be continuous. Now, once you plot it, you can tell. But before you even plot your point, that's how you can tell if this is continuous or not. B, we need the domain and range. So my domain is my x values. And so when I go from left to right, the first thing I hit is an arrow. And the last thing I hit is also an arrow. So this is negative infinity to infinity. All your domains are going to be this. Your range, however, is from bottom to top. So the most bottom thing I hit right here is at y is 2. Okay, it's not where it crosses this. That's an intercept. That's part C. I have a y value at 2. And it is included because it is a solid closed circle. So my lowest point is 2, or my lowest y value is 2. And then it goes up to an arrow, so infinity. And then C, we need intercepts. So x-intercepts, where is this crossing my x-axis? Well, it is not, so we don't have any. And then where is this graph crossing my y-axis? Right here at this point, 0, 3. And then we already did D, is this continuous? I'm going to go ahead and stop the video right here. And I will make a part 2 of this and show 2 more examples of how to graph piecewise functions.